Hello my dear student. Assalamu alaikum. How are you all? I hope all of you are doing well by the grace of Almighty Allah. I am Hafiza Khatun Konika, Milestone School and College, Sector 4 branch, Uttara, Dhaka. Today I will take your science class. Dear students, you already finished chapter 1, chapter 7, chapter 8 and chapter 9. Though your science exam is knocking at the door, so today I will just revise your previous chapter that you already finished. So students, from chapter 1 today I will discuss some topics. Then from chapter 7, chapter 8 and chapter 9 I will discuss some important topics. So let's start for today's class. Dear student, from chapter 1 I will discuss importance of measurement. Then I will discuss fundamental unit and derived unit. So first of all, now I will discuss necessity of measurement. Okay? Here you can see necessity of measurement. We usually depend on our assumptions while measuring things in various common situations in our life. For example, the length of your reading table, the time you start for school, etc. In such cases, you are most likely to answer the questions on the basis of your assumptions, right? Again, there are some other situations in our life when you cannot just depend on your assumptions when measuring something. Do you want any example? In order to determine in which group you will compete in the annual sports competition in your school or which television news headline you will follow, you must require specific information, isn't it? Like if you need information on your height and need to know the timetables of different TV channels for news updates. For these cases, you may not get the correct information if you depend on your assumptions for measuring your height or the time. Therefore, measurement is essential for determining a specific quantity or grade. We feel the necessity of valid measurement in every sphere of our life. Take some examples like if you want to purchase rice or dal from the grocers, if you want to make your clothes, or starting and finishing classes in time. In each of these cases, it is essential to measure accurately. Without proper measurement, it is difficult to decide how many pairs of table or bench will be accommodated in a classroom, how many rooms can be built within the certain area of a house, or which room will be of what size. Moreover, while cooking, it is essential to add exact amount of spices to the curry. Okay? Life-saving medicine is also manufactured by following specific measurements, and patients have to take medicines in exact amounts as prescribed by the physician. In fact, proper measurement is necessary in every sphere of our life. Dear students, so I think now all of you understood that why measurement is important for our life. Then our next topics, fundamental unit and derived unit. Fundamental units. Fundamental units are all those units which are independent of any other unit. On the other hand, derived units. Derived units are all those units which are obtained by multiplying and or dividing one or more fundamental unit with or without introducing any other numerical factor. Dear students, now I will tell you about differentiate between fundamental units and derived units. In the board, you can see the difference between fundamental unit and derived unit. Fundamental units are all those units which are independent of any other unit. On the other hand, derived units are all those units which are obtained by multiplying or dividing one or more fundamental units with or without introducing any other numerical factor. Then fundamental units cannot be further reduced to elementary level. In fact, these are elementary units. On the other hand, for derived units, it can be reduced to its elementary level, which are composed of fundamental unit. Then fundamental units cannot be expressed in terms of derived units, and on the other hand, derived units can be expressed in terms of fundamental units. Then next, number 4, for fundamental units. Only 7 fundamental units exist in metric system or SI system, where there exists a large amount of derived units in metric system. Then for fundamental unit number 5, 7 fundamental units are meter, kilogram, second, Kelvin, mole, ampere and candela. On the other hand, example of derived units are Newton, joule, watt, volt, Pascal, Celsius, etc. Students, now I will show you a small video on these topics. Hope you will enjoy this video, okay?
Fundamental and derived quantities. In our daily life, we use measurements many times. Can I get 2 kilograms of tomatoes? I ran about 3 kilometers today morning. Here, 2 kilogram and 3 kilometers are physical quantities. And these quantities are expressed as value with unit. Every measurement is expressed only in this pattern, value with unit. When we talk about physical quantities are of two types in general. They are fundamental quantities and derived quantities. Fundamental quantities. Quantities which deal with basic measurements and quantities which cannot be expressed in any other quantities are known as fundamental quantities. There are 7 fundamental quantities in System of International Units. They are length, mass, kilogram, time, temperature, electric current, amount of substance, and luminous intensity. Length is expressed with the unit meter. Mass is expressed with the unit kilogram. Time is expressed with seconds. Temperature is expressed using Kelvin. Electric current is expressed using ampere. Amount of substance is expressed with the unit mole. Luminous intensity is expressed using candela. So, here we have fundamental quantities to measure. Do you think it is possible to measure everything in the world just using fundamental quantities? Two boys are riding bicycle. To find which boy's bicycle is the fastest, we should consider the time taken and distance covered by them. So, to calculate the speed of bicycle, we use two quantities, distance and time. Here we calculate speed with a combination of distance and time. So, speed is a derived quantity. Any quantity which is a combination of fundamental quantities are called as derived quantities. In general, derived quantities are obtained by multiplying, dividing, or combining fundamental quantities. Examples of derived quantities are area, volume, speed, electric charge, and density. Area. Area is a combination of length and breadth. So, the unit of area is meter square. Volume is equal to length into breadth into height. So, the unit of volume is meter cube. As area and volume are obtained by combining two or more fundamental quantities.
Dear students, now I will discuss two topics from chapter 7. The name of chapter 7 is Properties of Matter and External Effects. Dear students, from this chapter I will discuss two topics, that is structure of matter and metal and non-metal. There are numerous types of matters in the world and they are classified in various ways. Among these, one of these classifications is based on the state of the matter. Let us take an example, okay? When a piece of ice is kept on a pot, what happens? It is converted into water, right? Again, we can convert it into vapor by heating it up. So, it appears that water can be found in three different states, that is ice, water and vapor. When water remains in the form of ice, it is in solid state. When it remains water, it is in liquid state. Again, when it becomes vapor or steam, it takes gaseous state. So, matter is divided into three groups depending on its states, like solid, liquid or vapor or gas. That is solid, liquid and vapor or gas. Students, now I will discuss solid state and characteristics of solid. A solid body has a definite size. The space occupied by a body is its volume. As all solid body occupies some space, they all have volume. The size and volume of a solid body cannot be changed easily. It is highly rigid, that is, it has rigidity. Then next I will tell you about liquid state. A liquid state has no definite size. It holds the size of the container where it is kept. Liquid has a definite volume because it occupies space like solid. Its volume can be also measured. Does this volume changes? No. Although depending on the size of the container, the size of the liquid changes. But the volume remains the same. As a liquid has no definite size, its size is changeable. Therefore, it can be said that the liquid is not rigid, like it has no rigidity. Now, next state, vapor or gas. Gaseous state has no definite size or definite volume. Okay. So, this is the characteristics for solid, liquid and gaseous matter. Now, I will tell you about metal and non-metal. We use various types of aluminium pots, gold jewelry, wire, which made of different kinds of metals. How do these metals look like? They look like glittering or shiny. This is common characteristics of most of the metals. On the other hand, we use aluminium pots or iron pans for cooking. Do you know why? Because they can transmit the heat from the oven fire to the main ingredients of cooking, and the ingredients get boiled due to that heat. Hence, another characteristics of metals is they can conduct heat. So, metals are called good thermal conductors. Okay. Again, what is the cause of use of copper for electric conductivity? To conduct electricity, all metals are electric conductor. So we can say that metal or metallic matters are shiny, heat and electric conductor. Then our next topic, non-metals. Can you tell how gases such as nitrogen, oxygen or hydrogen look? You will not be able to answer this question because these gases neither glitter like metals nor they have any visible feature to mark. Again, they do not conduct heat or electricity like metals. So, non-metals are called thermal and electrical non-conductors or insulators. Now I will tell you about solute, solvent and solution. Dear student, tell me which of sugar and water is available in larger quantity in the mixture of sugar and water? Undoubtedly, the amount of water is more and the quantity of sugar is less, right? Here, water dissolves the sugar and the sugar is dissolved by water. In a solution, usually the component that remains more in quantity, that is the component which dissolves the another component. The component that dissolves the other components is called solvent, and the components that are dissolved by the solvent are called solute. And now solution. What is solution? The mixture of solute and solvent is called solution. That means the combination of solute and solvent is called solution. Students, now I will show you a small video on these topics. Hope you will enjoy this video, okay?
Have you seen a food color mix in a glass of water? Does it mix completely the moment you put it in the water? No, it's a gradual process. And if you observe closely, you can see it slowly spreads in the water. Similarly, if you take salt crystals and put it in water, you might also notice that the crystal becomes smaller with time. We usually say that the salt is dissolving in the water. But what happens at a molecular level? Let's see in this video how exactly a solute dissolves in the solvent. Suppose we put salt in water. Now let's look at a crystal of salt dissolving in water. A salt crystal is made up of sodium and chloride ions that are arranged in a cubic lattice. In it, those ions that are at a corner or an edge are loosely held. And we know that water molecules are polar in nature with partial positive charge on the hydrogen atoms and partial negative charge on the oxygen atom. Now, as we put the crystal in the water molecules collide with the crystal until an ion breaks free. Since the ions are positively or negatively charged and the water molecules are polar, more water molecules are attracted towards that ion and they cluster around it. That is, if a positively charged sodium ion breaks free, the oxygen atom of the water molecules is attracted towards it. And in the case of negatively charged chloride ion, the hydrogen atoms of the water molecules are attracted to it. So we see that as water molecules collide with the crystal, a loosely held ion breaks free. Then more water molecules cluster around the ion, stabilizing it by means of ion-dipole interactions. The same thing happens over and over until there remains no crystal. We say that the solute particles are dissolving in the solvent, forming a solution. This process is called dissolution. But wait, something else is also going on while forming the solution. We saw that ions separate from the crystal and are stabilized by water molecules. But sometimes the free sodium and chloride ions collide with the crystal. Due to the strong interaction between the ions and the crystal, these ions become a part of the crystal again and separate out from the solvent. So as some solute particles are dissolving into the solution, some dissolved solute particles are also separating from the solution. This process is called crystallization. Therefore, in a solution there are two processes taking place simultaneously. One is the dissolution and the other crystallization. These two processes together give rise to a dynamic equilibrium in the solution. Initially, the rate of dissolution is much larger than the rate of crystallization. This means there are more solute particles mixing with the solvent than separating out. But as we add more salt to the solution, the rate of dissolution slows down and the rate of crystallization increases. A point is reached when the two rates are equal. So, if you look at the beaker, there is no visible change. We say that no more salt dissolves in the solution. But at the molecular level, solute particles are entering and leaving the solution at equal rates. The solution is in dynamic equilibrium with the undissolved solute. A solution in which no more solute can be dissolved at a given temperature and pressure is called a saturated solution. At this point, we've reached the maximum amount of solute that can be dissolved in the solution at a given temperature and pressure. This maximum amount of the solute is known as solubility of the solution. So we see that in a solution, two processes, namely dissolution and crystallization, occur simultaneously. As their rate becomes equal to each other, no more solute is dissolved in the solution and the solution is called the solution. Now notice that here we mentioned that solubility depends on the temperature and the pressure. So does it mean that if we change the temperature or the pressure of a solvent, we will be able to dissolve more solute?
Dear student, now I will tell you about universal solvent. You have know before about the solvent and the solution. What does universal salt mean? Do you know? It is such a solvent which is able to dissolve all kinds of substance. Is it possible to get such type of solvent in reality? What do you think? It perhaps is not. But the only solvent that can dissolve many kinds of substance in our well-known water. That is, water is only universal solvent found so far. Water can dissolve innumerable inorganic. Water can dissolve innumerable inorganic substance. It can dissolve many organic substance too. it can also dissolve gaseous substance. Discuss two topics, that is laws of reflection and regular reflection and irregular reflection. First of all, I will discuss on laws of reflection. There is two laws of reflection. Number one, the incident ray, the reflected ray and the normal ray at the point of incidence lie in the same plane. And then number two, the angle of incidence is the equal to the angle of reflection. Okay, so these are the laws of reflection. Then next topics, regular reflection and irregular reflection. Regular reflection. Here you can see the figure of regular reflection. Now I will tell you about it. The regular reflection is the reflection of light rays when they meet a smooth and on a smooth surface where the incident light rays are reflected in one direction. When a beam of parallel light rays is incident on a smooth and plane surface, the reflected ray will also be parallel. And this phenomenon is called regular reflection. Now, next topics, irregular reflection. Dear student, here you can see the figure of irregular reflection. Now I will discuss on irregular reflection. When a beam of light falls on rough, unpolished surface, such as wood, paper, the light reflects in different directions. Such a reflection of light from an uneven surface is called irregular reflection. The another name of irregular reflection is diffused reflection. Students, now I will show you a small video on these topics. Hope you will enjoy this video, okay?
In our previous video, we learned that we see objects around us because of the light reflecting from them. Some objects like the sun, burning candle and the fluorescent bulb emit light of their own. They are also called luminous objects. Many objects around us are non-luminous, that is, they cannot generate their own light. However, these objects reflect the light from the luminous objects from their surfaces. And because of this reflection, we can see such objects. In which direction do the luminous objects emit their light? They emit light in all the possible directions. Consider a fluorescent bulb which is glowing. It is emitting light in all the directions. Let us denote each direction with a straight line and an arrow on it pointing in the direction where the light is traveling. So all these arrows represent various paths along which light is traveling. These arrows are what we call rays of light. Here's how we define a ray of light. A ray of light is a straight line path along which light travels. So now we know that light emitted by luminous objects travel in a variety of directions. Suppose rays of light from this fluorescent bulb fall on the surface. It being non-luminous reflects these rays, and these reflected rays travel along a certain path. Consider this plane surface. Suppose one of the rays of light from the bulb strikes at this point. This is called an incident ray. We know that this surface will reflect this ray, and the reflected ray will travel in this direction. Why only in this direction? Why not here or here? This is because rays of light obey certain laws of reflection when they strike any surface. Draw a perpendicular to the surface at the point of incidence. This line is also called normal. Here are the two laws of reflection that any light ray obeys. To understand the first one, we first need to know what angle of incidence and angle of reflection are. The angle of incidence is the angle made by the incident ray with the normal. It is denoted by I. The angle of reflection is the angle made by the reflected ray with the normal. It is denoted by R. So our first law says that the angle of incidence is always equal to the angle of reflection. I is equal to R. Here, as I is equal to R, if the incident ray strikes at this point, then the reflected ray will travel along this direction only so as to keep the measure of R same as I. If I move the incident ray here, then the reflected ray will also move to keep the measure of R same as I. I is always equal to R. Okay, so this was about the first statement. What about the second statement? The second one tells us that the incident ray, reflected ray, and normal all lie in the same plane. So if I draw this scenario on the piece of paper, I will get this. Incident ray, reflected ray, and the normal, all three are in the plane of the paper. The second law tells us that they will always be on the same plane. For example, if the reflected ray is in this direction instead of this, then the diagram will look like this. The incident ray and normal are in the plane of the paper, whereas the reflected ray is not in this plane. This violates our second law, and hence this ray will not be reflected in that direction. This is just not possible. It can only be like this. I will be equal to R, and they will lie on the same plane. I hope both the laws are clear now. In the next lesson, we will see an experiment based on this concept which you can easily perform.
Dear student, here you can see some related question. Question number 1, what is fundamental unit? Question number 2, what is derived unit? Then next question, question number 3, write the characteristics of solid, liquid and gaseous matter. Then next question, what is metal? Then what is non-metal? Then question number 6, why water is called universal solvent? Then question number 7, what is regular reflection? And then next question, what is irregular reflection? Dear student, please learn this question in your home, okay? So students, that's all for today's class. Thank you so much for joining. See you soon. Thank you so much. Allah Hafiz and Assalamu Alaikum.